Momentum is the product of mass and velocity. Large force acting on a body for a short interval of time. The rate of change of momentum, not simply body A is imparting velocity to the body B, that for every action there is an equal and opposite reaction. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. Thought for the day before we start our session. A true respect to oneself is the ability to depend on your confidence. The more confident you are, the more potential you have, and you get more respect. Be confident, you will reach the heights of success. In my previous class, students, we had discussed the chapter Laws of Motion, where from the first law we understand that any particle or any body which is at rest continues to be at rest until an external force acts on it. Any particle which is moving in a straight line continues to move until an external force acts, which means force is an external agent causing a change in the position of an object. And we also learned something called as inertia, which was the disability, the incapability of a body to change its position by itself. And we told the physical quantity which measures inertia is mass. Today, we will understand the second law of motion. Before understanding the second law, we will try to define a term called as momentum, because the second law is all about understanding what momentum is. So we will get the definition of momentum by understanding the following example. I consider two bodies. The first one is A and the second one is B. Two bodies, A and B. And I say the body B is at rest, which means to say the velocity of the body B is zero. It is at rest. It doesn't possess any velocity. So, I have considered two bodies, A and B. The second body, B, is at rest. Its velocity is 0. Now what happens? A is moving with a certain velocity. It moves towards the body B and it strikes the body B. The body A, which was moving with some velocity, it moves towards the body B and strikes that body. And now I observe even the body B starts to move. When I say starts to move, it means even body B has gained some velocity. Who has given body B that velocity? It is A. Cricket al kelirಬಹುದು. After the 15th over, the innings is catching momentum. Kohli's strike are far behind his momentum. Momentum andre, it's a type of intensity, fearful act anta helbodu. The proper definition of momentum is, it is the ability of a body, the capacity of a body to impart velocity to another body. We define momentum as the ability of a body. The body A is imparting velocity to the body B. And therefore, the body B is set into motion. So A is imparting velocity to body B. It is setting momentum in body B. So we say the ability of a body to impart velocity, give velocity to another body is what we call as momentum. Kohli imparts velocity to the innings. He is gaining momentum with the innings. He is imparting some intensity to the innings. So momentum is the ability of a body to impart velocity to another body. And therefore, momentum mathematically is defined as the product of mass and velocity. We write momentum vector P is the product of mass and velocity, which is vector V. Very, very important mathematical notation. Momentum is the product of mass and velocity. Vector P equals m into vector V. So what is its SI unit? Mass is kg. Velocity meter per second. So kg meter per second is the SI unit of momentum. What is its dimensional formula? Mass is m, velocity LT minus 1. This is the dimensional formula for momentum. So, my dear students, physically we told the ability of any body to transfer velocity, impart velocity to another body is called momentum. And mathematically, it is the product of mass and velocity. Note, it is a vector quantity given by vector P equals m into vector V. Now, with this definition of momentum, we will study a very important law, called Newton's second law of motion. Newton's second law says the rate of change of momentum is not simply talking about momentum. It is rate of change of momentum is directly proportional to the applied force and takes place in the direction of the applied force. The rate of change of momentum, not simply momentum acting on a body. Rate of change of momentum is directly proportional to what? Applied force and takes place in the direction of the applied force. Which means to say, rate of change of momentum dP divided by dt. P is momentum. dP by dt, rate of change of momentum. Rate with respect to time. Change of momentum with respect to time. Rate of change of momentum is directly proportional to the applied force. By definition, momentum is the product of mass and velocity m into p. So d by dt of mv is directly proportional to f. d by dt of mv. How did I get that mv? It is the product of mass and velocity, which is momentum, directly proportional to f. Can mass change with respect to time? No. Under any condition, classical mechanics told mass is a constant. So m dv by dt is proportional to f. What is dv by dt? Good. Rate of change of velocity is acceleration. So m a is proportional to f, which means eliminating the proportionality, ma is k into f. If k is 1, then F equals ma. This is the expression for force from Newton's second law, where we say force is a product of mass into acceleration. So dp by dt, what is that? Rate of change of momentum directly proportional to F. Momentum is mass into velocity. Mass remains constant. M dv by dt proportional to F. dv by dt, rate of change of velocity, acceleration proportional to F, or force is mass into acceleration. So very clearly we told the rate of change of momentum is directly proportional to applied force, and it takes place in the direction of the applied force. Now we understand something called impulse of a force, a concept what we understand as impulse of a force. It is a large force acting on a body for a short interval of time. Very beautiful definition. Large force acting on a body for a short interval of time. Can I get an example for that? Yes, kicking a football. I apply large force for a short interval of time. The moment force is applied, the ball flies. Large force for a small interval. Striking a cricket ball with a bat, the bat exerts large force on the ball for a small interval of time. And that is what we call impulse. So impulse is a large force acting on a body for a short interval of time. Therefore, we write impulse is force into time. The mathematical definition for impulse is force into time, and the SI unit is Newton second. Now I need to write the dimensional formula for impulse, which is equal to force into time. Force is mL t minus 2, mass into acceleration. Time is t, or this is m L t minus 1. So this is the dimensional formula for impulse. Now a small assignment for you all kids. You have to prove that impulse of a force changes the momentum of a body. I have clearly told impulse, large force acting on a body for a short interval of time. Impulse is the product of force and time. So I've asked you all to prove that impulse changes the momentum of the body. Now, a very famous law, always at the tip of the tongue, Newton's third law, which clearly states every action has an equal and opposite reaction. We have learnt from Newton's third law that for every action there is an equal and opposite reaction. Point number one, what we need to understand is action as well as reaction, they are a type of force. Action as well as reaction is nothing but force. Understand. I stand on the floor. My foot will exert some force on the floor. That is action. My foot, my leg, it is exerting some force on the floor, what I call as action. In turn, the floor will exert a force on my foot, which is reaction. And what Newton's third law says is, action and reaction should be equal and opposite. Both should have the same magnitude, but they should act in opposite directions. Both action and reaction, they should have the same magnitude, but they should be acting in opposite directions. And that is why we say, for every action, there is an equal and opposite reaction. I consider two bodies, A and B. Body A will exert some force on body B. That is what we call as action. F, A, B. A exerts some force on body B. Action. That is F, A, B. In turn, body B will exert some force on A, which is FBA, and I call this reaction. Newton's third law says action should be equal to reaction. They should have the same magnitude, but act in the opposite direction. So wherever there is action, there has to be an equal and opposite reaction. Then, my question is, wouldn't the net force acting on the system become zero? Then what is the use of action and reaction? No, the force doesn't become zero. Why? Because action and reaction are forces acting on two different bodies. They don't act on the same body. They act on two different bodies. Very clearly you can see. That is why the net external force cannot become zero. Don't have a misconception that the total force reduces to zero. No. Here, both action and reaction act on different bodies, hence it doesn't turn out to be zero. So today, we learned concept called momentum, where we defined momentum as the product of mass and velocity, through which we understood Newton's second law, which says the rate of change of momentum is directly proportional to the applied force and acts in the direction of the force. We understood that impulse is a large force acting on a body for a short interval of time. And the third law says, wherever there is action, there has to be an equal and opposite reaction. My next class, students, we will understand the law of conservation of momentum. Until then, have a nice day. Thank you.